message me whenever there's something wrong. I hope it goes fine today. All right, so let's get started with classes. Um, so that's one of the most important concepts of not just one of the, it is the main concept of C++, and that is what helps to make it an object-oriented programming language. So along with that, we'll see what encapsulation, accessibility, constructors, destructors, and all those mean. All right. So we have briefly seen about different types when we discuss about structures last week. So these structures, classes help us to create a new type other than the data types we already know. So we know about integer, we know about float, but these classes help us to create a brand new type on our own, or it is also called a user-defined data type. All right. Um, so you can categorize types into any way you feel appropriate. Like for example, you see some animal on the road and you don't know what sort of animal it is, but you know it is an animal. So these are all categorized as animals. Or there is some plant, you don't know the name of it, but you still know it is some sort of a plant. So these are the items based on which we categorize it. So basically in these cases, our types are going to be, one is going to be animal type, the other one is going to be a plant type, and so on. So we create classifications based on our requirement. And these are then termed as, and these are then created using classes. So an example is an orange is a citrus type, a citrus is a fruit type, a fruit is a plant type, and a plant is a living thing. All right, so that is again another type. So other types of things can be cars. So see, for example, you've got a Honda. So that comes under the classification of a car. So you don't know whether that's a car can also be classified as whether it is a sedan or whether it is a four-wheel drive. So these are different ways in which you can classify cars. Or you've got houses. So say maybe an independent house, or maybe what do you call it, a duplex or whatever. All right, or a townhouse. So these are classifications that come under house, person, shapes, and so on. So shapes is more, I mean, shapes is easier to think of. So under shapes, you can have circles, triangles, squares, and so on. So in C++, basically a type is an object. An object is what you create out of these classes. All right. So an object is something that has got a particular size, like your common data type. So your built-in data types, like integer has got a size of 4 bytes, or a floating point has a size of 4 bytes. A char or a character has a size of 1 byte, and so on. So in the same manner, the object that you create, the object that is a user-defined data type, an object that you create out of that user-defined data type will also have a size. Plus, it will have a set of abilities and a state. So the advantage of creating a user-defined data type is you decide what are the features of that type, you decide what functionality it should have, and what size it needs to have. So it's all your responsibility. All right. So why do we create a new type? Basically, to solve all our real world issues. I mean, not all the real world issues, what can be solved through software, basically. So the advantage is that we are able to structure our problems, our project in such a way that these are all structured under different categories. All right. Say for example, in your game, you've got your enemy character, your player character, and what else? And the some other superpower or something. So each of these will have different characteristics, different responsibilities to perform. Like the responsibility of the player is to maybe to reach the uh, a target destination or something, and cross over all the obstacles. The responsibility of the enemy is to try to hinder, I mean, try to kill the player or hinder its or I mean, like gives some obstacles to the player. So there are different responsibilities to each of these categories, and that's why these are all going to be different types in your game, because they have different responsibilities, they have different characteristics, so they are going to be different types. And in our program, these are going to be different classes. All right. So basically, you can make any new type just by declaring a class, and a class is going to be a collection of variables along with a set of functions. So it is these functions that basically say that these are the responsibilities of the that each of these functions are going to be the responsibilities that's going to be performed by these classes. All right. So if you think of a car, the characteristics of the car would be how many wheels it has, how many doors it has got. I mean, okay, how many doors it has got, how many seats it has got, how many windows, and so on. So you can take a note of all of these. So we can say int wheels, int number of wheels, int number of windows, int number of seats, int number of window. I mean, and so on. If these are relevant to your project. So do not simply create characteristics just for the sake of it. Only if it is relevant for your project. Because remember, the number of characteristics you create for these classes, the size of your class is going to be as big as the characteristics. So you wouldn't want to simply increase the memory requirement. And what else does a car do? So a car can do specific speed up, slow down, and so on. So these are functionalities that can be performed by the car, and these are going to be your functions. So a class is going to be a collection of variables plus a set of related functions. Now, it is this the meaning of encapsulation is basically bringing together all these information into a single object or into one single place. Okay. So that is again one more advantage of going for a class. You could so far, but say you're asked to create some game where you have a player, you have got many enemies, you've got maybe some superpower. So how would you create variables out of this? What you would need to do is maybe say char player name, maybe int player score, int player lives, and another one called char enemy name, um, then bool enemy alive. So these are different variables that could be lying around in many places in your code. But classes help you to bring all these characteristics into in one place. So you've got a collection of characteristics for your player. Bring it all into one single place. That is under a structure or under a class called player. So when you go into the class player, you've got all these attributes like player name, player score, player lives, and maybe other um, any other add-ons you would have given to the player. Similarly for the enemies where the enemy is alive or not, the type of the enemy, and so on. So that can be under the enemy class. So you basically encapsulate everything that you want for for an object into a single position, into the same position. So it's easier to refer. It's easier for any other programmer to understand what uh, what are the characteristics of your character, or what are the characteristics of your object, and what functionalities you offer. Okay, so you can encapsulate everything into a single place in order to make it easier to refer, easier to copy, and easier to manipulate. So when you create your class, you will be having other clients, meaning you will be having other classes or functions that will make use of your class. All right. So when other functionalities or when other classes or when other programs, they do not actually need to know how each of these is implemented. All they want to know is what functionalities are offered by a class. All right. They do not need to know how these functions are operated. They only need to know what is offered. And that is the reason we keep saying that you names for your functions and meaningful names for your variables. Goes for class as well. So wherever you need to give a name like a class name, a variable name, a function name, give meaningful names so that when other people try to use it, they will be able to easily understand. All right. Commenting the code is of course important, but it's even more important to give classes and your functions and your variables. Okay. So that whenever the functionalities of your they know what your class does from the class name and they know what a particular function does. So all they do is just make a call to that function and then they are done there. Because you are not going to give them information about how it is implemented. The only thing you say is, say you have something called a shape class. I mean, say you've got something like a circle class and you say float calculate area. So it's clear from the function name, calculate area, that the purpose of that function is to calculate the area. Calculate the area of whom? Calculate the area of the circle because it comes under the circle class. So anybody else would just call the calculate area function and they know they're going to get the result. So that is again another property that is offered by your class, where you just need to tell the outside world what it performs and you do not give it any more information about how it is going to be done. Information cares about what is performed by a class but not how it is performed. So your class is basically consisting of properties and methods. So properties are offered by member variables, which are also called the data members, and these are the variables in your class. So these variables can either be created your already existing data type, that is your built-in data types like, or you could make use of another user-defined data type. Whenever I use the term user-defined data type, understand that it is coming from a class. So maybe say you've created something like an engine class. All right, so an engine class has its own features defined there. So there was some reason you wanted to create an engine class because you wanted to perform some functionalities there. And then you've got a class car. So a car requires an engine. That's why it will have a variable of type engine inside the car class. Okay. So inside the member variables, you can have as many variables as is required for your project. So that is the member variables part. And the other one is member functions, which is also called the methods. All right. So these methods manipulate the member variables. So these functions have the freedom to access your member variables and then to perform any operation on it based on how you define. So these member functions basically determine what your class can do. Okay. So any doubts so far? I can see there is are static classes a thing? Um, Static classes are generally not used. I mean, static classes. I think these are in C sharp. Not in here. You will be learning something called a static concept, but it's not classes exactly. All right. Okay. So let's get into how we declare a class in that case. So class is declared simply by giving the class keyword. You give a class keyword and a meaningful name for your class, followed by curly brackets. Within the curly brackets, you define all the data members and the methods of the class, and you end it with a semicolon. All right. So the semicolon is very important. If you miss out the semicolon, then remember you're going to end up in a lot of compile time errors. So be very careful with the semicolon. All right. It's the same rule as we had done for structures last week. Basically, structures came from C, but its additional functionalities were obtained from classes. Okay. So to declare a class, you use the class keyword and then give it a meaningful name. So in this example over here, the name of the class is CCAT. And what I need for this particular project maybe is just the age and the weight of the cat. All right, so that's why you've just got an I age and an I weight here. And the functionality is just a meow or whatever it does. All right. So Bravo, when would you use a struct instead of a class? A class is always a class is always going to be a class is always going to be a first preference whenever you have um whenever you want to define member functions and variables in the class. All right. You go for a structure only if you're only looking for data member storage. That is only variable storage. If you do not have any functionalities that you want to define for that structure, then go for a struct. All right. But that being said, I'm not saying a structure cannot function like a class. A structure is also allowed to have a function, but that is only because because a structure was basically extended from its usage in C to C++. All right. But in C++, what we try to do is we try to limit structures to only what was allowed in C. That is, it is only allowed to hold data members in there and not any functions, not any related functions. And classes was created so that it could hold the related members as well as functions. So that's why we try to keep the usage at that. There is also another major difference between structure, which I'll just discuss when I get to that slide. All right. So yeah, declaring this class cat class does not allocate memory for a cat. Okay. So remember, whenever we declare the classes, we're not allocating memory. It's just a blueprint. It's just a definition. It has still not been allocated memory. So even in the case of built-in data types, when does it get allocated a memory? Only when you say something like int score. So score gets allocated a memory in your memory space. So in the same manner, it's not getting allocated memory. You're just defining what the characteristics of the class are. Of these many, I mean, so many members and so many functions. That is the only thing you're saying. You've not created a variable out of it. You've not created an object out of it. Only when you create an object or a variable out of this user-defined data type will memory be allocated. Okay, and how is the memory allocated? The memory is allocated based on how many data members you have. So if we go back to the cat example, the cat has got unsigned int I age, unsigned int I weight, and the next one void meow. That is a function. So we do not consider functions. We do not consider the memory space for a function because functions are all in the code space. The memory space is just for the data members. So over here you've got 4 bytes for I age and 4 bytes for I weight, and that is 4 plus 4 is equal to 8. So if you create an object out of CCAT, it is going to be allocated a memory space of 8 bytes. All right. So be very careful about how many members you have, because the more members you have, the more memory it's going to take up. Okay. So use sensible naming conventions for your variables, for your functions, and for your classes. All right. Because that is the only way anybody else or you yourself can understand what it is supposed to do. We cannot read through comments every time to understand what it is. We have to understand it first from the names of the variables and the functions and classes. And remember, C++ is case sensitive. So if you say something like meow in small letters, if you say in lowercase, if you say MEOW, that is not the same as the meow that is specified in this case. Why do we do chase meows? That is just a naming convention, Hamish. Um, so the naming convention that we follow is that every uh, we do not follow. I mean, we do not write an underscore there. So every second word over there starts with a capital letter. It's just a naming convention. All right. Probably in whatever company you work later, they might have a different naming convention over there. It's not C++ specific, like I said. It's it's just what's generally followed. It's the current trend, you can say. All right. So when you go to a different company, you might have another naming convention over there. Okay. So if you use a different naming convention, remember it's not going to throw you an error. But for a good programming practice, it's always best that you use a standard naming convention and it's consistent throughout. Okay, so any doubts there? I just see a lot of people doing different stuff. Yeah, if you look online, you would see that each of the people would have followed different naming conventions. So here, I'm not specifically. What is important for me is that you follow a consistent practice. So if you're following a particular following naming convention, then make sure it is consistent throughout your code. But this is a generally followed one. This is the most commonly followed one. So if you practice this, then it is going to be, or it'll automatically come whenever you go for any interviews or something. All right. Okay. So now let's see about how we define an object. So we have created a class called C class over here. How do we create an object out of this? Like we did in the case of structures, all we need to do is just use the class name followed by your object name. So we're saying ccat whiskers, and at this point, a new object called whiskers is created, which is allocated a memory of 8 bytes. 8 bytes because 8 bytes is the size of the data members in your ccat class. All right. So it is only at this point there is memory allocated to the object of the class. Okay. So here you can see the difference between the two. One variable is created out of a built-in data type called integer. The other one is created out of a user-defined type called ccat. All right. So creating objects out of classes is pretty simple. Just use a class name followed by a meaningful object name. Okay. So again, reiterating that, remember, a definition is not allocated memory. It's only objects that get allocated memory. All right. So a simple way to think about it is you never pet the definition of a cat. You pet only individual cats. Okay. All right. So an object is simply an individual instance of a class. Okay. So whenever you create an instance of a user-defined type, that is your object there. Okay. So any doubts until now? I doubt we are going to be able to complete this week, but I'll try to get done as much as possible, and you can go through. Whatever I do should be sufficient for you to start off your project at least. Okay. So now once you define your ccat object, so we've created a whiskers object in this case, we should be able to access the members, right? So you need to say the data members of the ccat was one was I age and the other one was I weight. So we need to give values to it because otherwise it will consist of garbage values. Remember, any memory space would consist of garbage values. So until you allocate some and until you give it some meaningful value, it is going to print out garbage values. So how would you access these data members? Just using the dot operator. This again is the same as what we did for structures last week. Okay. Here the name of the object is whiskers, and you just need to say whiskers.iWeight is equal to 50, and maybe whiskers.iAge is equal to 3 or something. And to call the member function there, it is again in the similar way. You just say whiskers.meow. So any member over there can be accessed with just the dot operator. Use a dot operator and call the name of the function or the name of the data members. All right. Okay, Jacob, I'll just wait for your comment. Can you put an array inside of a class? Yeah, you're allowed to put any any relevant data type. You're allowed to create any relevant variable in a class. It can be an array. It can be the object of another class, as long as it is a relevant data type. All right. So yeah, just reiterating the fact that um you should your class does not have an existence. It's just an object that has existence. If you say something like ccat.iage is equal to 5, that is going to be wrong. It is going to give you a compile time error, because it is the same as writing int is equal to 5, which, as you know, is wrong. All right. So remember, if you say ccat.iage is equal to 5, it's the same as saying int is equal to 5, which is wrong, because ccat is not allocated memory. Ccat is just a definition. You get an instance out of it only when you say ccat whiskers. All right. So create an object out of it, because it is only a particular existing object. It's only an instance that can be allocated memory. And then you can say whiskers.ih is equal to 5. All right. So I hope you've got that clear and you won't make the mistake of assigning values to classes. So if that is clear, let's go to another concept that is about access specifiers. All right. So what we mean by access specifiers is we are allowed to give we are allowed to define the access we are allowed to give access permissions to the different members of your class. So two of the different types are public and private. Other than this, there's also something called protected, but you have still not learned enough to understand what protected is, so we'll just talk about public and private for now. Okay. So by default, all the members of a class are private. So in the previous example that we had given about ccat, we hadn't mentioned any public or private there. So which means that all those members are private by default. What private means is these members can only be accessed within the methods of the class. That is, within the member functions of the class. Nothing outside these classes can access the members. Only the member functions of the class can access the private members. Remember, it's not just members. If you don't mention any public there, all the member functions also become private by default. So when I say data members, it's including when I say members, it's including the data and the methods. All of them become private by default. If you want these to be accessed from outside the class, you need to mention public access specifier over there. Okay. So in this example, where we had ccat, we had ih, iwait, meow. So we have neither mentioned private nor public, but a class always makes all its members private by default. All right. This is because it wants. This is because the purpose of the class is also to make its members abstract. That is, it is providing only the required details to the outside world. Okay. So unless you specify that these are public, this is not going to be disclosed to the outside world. Or in other words, any function or any class outside this class cannot access any of the members. So if you create a ccat boots, that is an object out of this class, and you say boots.ih is equal to 5, this is going to throw you an error. All right, because this is outside. Whatever we are writing over here is not within the class, it's outside the class. So you've created an object, that's fine. You can create an object. Memory of size 8 is allocated for boots. But if you say boots.ih, the compiler finds that IH is a private member. And since it is a private member, the outside world, that is anything outside the class, does not have permission to access it, and it is going to throw you an error. So that is one of the main concepts of classes. Okay, so how would you solve that problem? Just put a public access specifier there. So you just write public followed by a colon before any of those members start. All right. So when you say public colon, everything below that statement there, everything below that access specifier there is going to be public. So we hear IH, iWait, and meow are all public members. So anybody outside the class can access either IH, iWait, or the meow function, and it is going to compile without a problem. But remember, do not blindly give any data member a public access, because that basically breaks the intention of the class. A major advantage of classes is that it allows it to control its access to the outside world. All right. So if you simply give public on top, and if you give all the members, make all the members public, then you're just breaking that idea altogether. All right. So I guess a couple of you have doubts. I'll just wait for your. Can I switch between? Yes, you can. So say you've got public over here, and after maybe around 5 lines, you give private. So that means all the remaining lines after that private specifier is going to be private. You can keep switching between public and private. How would you assign value to a private member like them? In this case, I mean, in case the IH is a private member, then you will need to make use of a public member function, which takes care of assigning value to IH. Okay. I will show you something similar to that now in the coming slides. So for private members, you will need to have some public which will assign value to it. Okay. Just wait for Dylan, what Dylan. Do you specify an end to public list, or do you we just write public? Everything below that public, if all the members below public becomes public members. If you want to change the access specifier at any point, you just mention a private before the point that you want to start. Okay. Otherwise, everything until the end of the class becomes public. Until it's either the end of the class or until another access specifier is specified. Okay. So I hope that's clear. Okay, so as a general rule of design, remember to keep the member data at least of a class private. Okay, so we at least want to give a private specifier to the data members so that the outside world cannot directly access at least the data members. So we try to use member functions for accessing every data in your class. And these methods that are used to access the data members, that is only for the purpose of maybe setting values to the data members, are called accessor methods. All right. The purpose of accessor method is just to set and get the private member variables. So what do you mean by set? Set is basically setting the value of the member variable. Get is to return the value of the data member. Okay. Or to get the value of the data member. And these accessor methods will need to be made public. Okay. So remember that whenever you give an access specifier, everything from that point to the end of the class or until the next access control keyword will be either public or private, depending on what you've given there. And also don't forget to end your class declarations with a closing brace and a semicolon. Okay. So we have this example. So in this example, 3 of these members are all public because there's no other access specifier there. So starting from int IH, everything below it is public. But what about this example CCAT? Here you can see there is a public access specifier before these functions. So you've got void star, the start function, accelerate function, break function, set here, get here. All of these are public. But after that, you see a private access specifier. So private colon, and below that, all the members become private. So the MI here and the MC model are all private data members. Okay. Again, below that, maybe after a couple of lines, if you give another access specifier, the private access stops there, and the next accessibility begins. But please make sure you do not give public, private, and so on. If you give public at a point, try to give all your public definitions at that point. And after you start the private, try to include all the private definitions there. Because if you go on giving public, private, it's going to be really confusing for anybody looking through your class declaration about what all the public members of your class are. All right. And the reason we have given public on top over here is and not private is because for the outside world, they can only access your public members. So they are only bothered about what your public members are. And that's why we have given this at the start of the class so that they can see what functions they are able to access. Okay, so they can access the start function, accelerate, break, and so on. And that's why all these functions are given at the start of the class. This is just for the purpose of providing ease to the others accessing your class. So are you clear with this? Okay, I don't see any doubts. All right, thank you. Yeah. So in this case, as you can see for this example, the MI here and C and in other words, all the data members are private. You wouldn't be able to access any of the data members directly. All you can access are just the member functions provided there. All right. So what we would do to access them is we create an object out of CCAR, say old faithful, and then you can say old faithful dot set here and pass a value there. So when we see something like set and get, what we are assuming is the set here sets the year data member in your class, and the get here returns the year data member from your class, all right, or from your object. I only call it an object. So set here basically sets the year value of the object, and get here returns the year value of the object. And that is the purpose of these set and get functions. These are the accessor functions, which will help you to access the data members of your class. Okay, so to set the year variable, just call the set year function and pass the data and pass the value. And remember to clearly declare your set year function with the relevant parameter there. And in the definition, do set the data member of the year. All right. And if I call the get year function, the get years obviously are to return the year. So I can declare an integer variable over there to get the value of year. So these are good programming practices where you have accessor methods for your variables. If for some reason you don't want your variables to be accessed at all by any outside world, you do not need to provide any accessor methods for it. All right. So yeah, look at this example over here. Where we have got the ccat function, which is defined in a new way with the public functions and with the private members. All right. So one more thing I want to add on over here is it is not necessary that all member functions should be public. You can have member functions which are private as well. But be careful in this case because if the member functions are private and if you try to access these member functions, it's going to throw you an error. Okay. So maybe for some reason you don't want the member function to be accessed in the outside world, you can make it a private. Okay. So how do you declare classes? Generally, all the class declarations are done in a header file. I'll come to header file if we have time today. Otherwise, I'll look into that next week. Okay. So on Visual Studio, all you do is just basically add a new item, and then you can just select header file in there. So far, we have only created source files. In the same place, you would also find add new. In the add new item, you would also find a header file, and that's how you create a header file. So it is one header file for one class. So say you've got a CCAT class, you create a header file called CCAT, and within that header file, you declare your class. So in the CCAT, I've got three member functions, which are all declared as private, and a data member, which is a private. Okay. Now these access a method, and now these definitions, these are all called definitions. So here I'm defining the member functions of the CCAT. These definitions are going to be in a source file. That is going to be a new source file again. It is not the same source file as your main source, as your main function. You'll have a new source file, which is the same name as the header file. So if you have ccat.h, you'll also need to create a new source file called ccat.cpp. Okay. So these are all good programming practices. All right. So inside the source file, I am defining these functions. Okay. So I've created, as you know, whenever you have a function declaration, you also need to have a function definition. Otherwise, it's going to throw you a linker error, because when you call that function and if there's no definition, obviously it cannot be implemented. So now to define the function outside the class, what we would do is we need to use the class name and a double colon. Class name followed by two colons. Okay. So instead of just writing int get age, like how we had done earlier, we would just write the name of the function and then define it. We also need a ccat and two colons following it in order to indicate that this get age function comes from the ccat. All right. So just before the name of the function, include the name of the class as well, along with two colons there. And then define your function. So same in the case of set age, you have your data type, so that is void. Set age is the name of the function. So before you write the name of the function, write the name of the class as well. So it is ccat, double colon, and set age. And the rest is the same. And then you just define the function. Same in the case of meow. So you've got void. Before the name of the class, before the name of the function, write the name of the class. So you've got void, ccat, double colon, meow, and empty parenthesis. And then you define the function. And that's how you define a function outside a class. All right. So yeah, that is how the definition goes. And then you can just create an object out of C, call the set age function. So the set age and the get age are the accessor functions there, because age is the only data member. So you only need accessor functions for one data type. So you set age to set the age of the whisker cat, and then you just call the meow function, or maybe the get age function to get the value of the whiskers. All right. So that is how you access the members of the class. So any doubts until here? About classes and accessibility and encapsulation. The next few concepts are about class constructors. How many more do we have? About constructors, destructors, and so on. All right. I'll just briefly tell you what constructors and destructors are, because we are already we're already at 12:20, I guess. Or are we only 12:15? It's only 12:15. Can I go on until 12:30? So that you have as much knowledge today and you can go forward. Okay,
Yep.
thank you. All right. So yeah. So constructors are basically functions of your okay. Constructors are basically functions of your class that get called whenever you create an object out of the class, whenever you create an instance out of a class. So these functions get automatically called whenever an object is created, or you can say whenever an object is constructed in memory space. These functions get called. All right. So the purpose of these functions are to initialize your object, to initialize the data members of your object. And that is the purpose of these constructors. Destructors is the exact opposite. Whenever the object gets destroyed, then the destructor functions get called. All right. The purpose of a destructor is basically like a cleanup action. So remember we had discussed about dynamic memory allocation. You had where you could allocate memory in a free store, in a heap memory, using the new operator. So I had also mentioned that when the usage of that pointer is over, you need to free the memory, because a heap store memory is a limited memory. And when you're done with its usage, you need to free the memory so that it is available for other data members. And if you don't free that memory, remember, through the entire code execution, it doesn't get freed, even though you are not able to access it. So it's very important that you remember to free the memory by using the delete operator. So it is mainly in these cases that you would need a destructor. Because whenever you go for a new operator, the compiler is not going to free the memory by itself, even though you have come out of the scope. You will need to explicitly say delete in order to free the memory. Okay. Whenever you have pointer members in your class, which you have allocated memory using the new operator, remember to free the memory using delete inside the destructor function. So yeah, that's your constructor and destructor. A constructor gets called whenever a new object gets created out of your class, and a destructor function gets called whenever the object gets destroyed. All right. So basically, a constructor's operation is to initialize data members, and a destructor's function is to do a cleanup function. Okay. Why isn't this going forward? Okay. Sorry about that. Oh, great. Okay, I don't know what went wrong there. Can you all see my screen now?
Mm-hmm.
Okay. I'll just try restarting that again. What slide are we on now? Okay. So, constructors have a special way of creating being declared. So a constructor does not have a return type. Though it is a function, it does not have a return type. And the name of the constructor is the same as the class. All right. So your constructor can have parameters there. Maybe you can have one parameter, two parameters, or depending on how many data members there are, you can have as many parameters there. Okay, because the purpose of a constructor is not to perform any other function. It is only for initialization purpose. And obviously, you're trying to initialize the data members. So if you have a number of parameters there, then those parameters should match the number of data members. Okay. So, like I said, a constructor does not have a return type, so you can see neither. I mean, no data type, nor can you have anything like a void. That is the only way you can recognize that this is a constructor of a particular class. All right. So if you have a class called ccat, the constructor name is also going to be ccat. And just that. All right. You could have parameters depending on the data members that you want to initialize. Okay. So you cannot hear anything. Mm, let me see what's gone wrong there. Okay, Rehan, maybe you can try reconnecting in that case because I think the others don't have any problem.
Can you hear now?
Okay. Okay, since the others are able to hear, I think it's working fine. All right. Yeah. So same goes in the case of destructor as well. There's no return type for the destructor, but a destructor is also not allowed to have any parameters. Okay. So a constructor could have parameters, but no return type. So there could be maybe maybe empty parameters, no parameters there, which is also called a default constructor, or one parameter, two parameters, depending on how many data members you got. But a destructor is not allowed even a parameter list because a destructor doesn't need one. The only purpose of a destructor is to free up the memory. It's not going to initialize any data member. So why would it need any data members anyway? The only purpose is to maybe free the memory space occupied in a heap memory, or usually it's always in that case. All right. Or maybe some action you want to do before it gets destroyed. It's not for any initialization purpose. But a tiny difference you can see over here is this till operator. All right. Your mic is playing up. Okay. Um, I think we'll stop at this point then.
Thank you.
Are you can see here? Okay. So a destructor has a tilde operator followed by the name of the class. And that is how you understand whether it's a constructor or a destructor.
I have a
So this
question.
difference between a constructor having no parameters and a constructor having multiple parameters. So a constructor having no parameters is called a default constructor. So when does a default constructor gets called? Say you create an object in this manner, like how we have created so far. We are just saying ccat whiskers. So in this case, it is going to call a constructor with no parameters. All right. since you're not passing any values there. So it calls a default constructor. But in case you say something like ccat whiskers and you pass a value 5, then the compiler will look for a constructor with one argument. All right, so it invokes a constructor that is called ccat with one integer argument. If the compiler finds that a constructor with one argument is not declared, remember it's going to throw you. Okay, so create as many constructors as required for your class. If your class has got 3 parameters, create a constructor no with no parameters, with 1 parameter, 2 parameter, and 3 parameters. At a minimum, your class should at least have a constructor with no parameters and another constructor with 3 parameters if you've got 3 data members in there. Okay, so a default constructor and a constructor containing as many parameters as your data members should be present at a minimum. Okay, so usually your classes do provide default constructors which doesn't perform any action. Okay, so by default there's always a default constructor there, because even if you don't have any constructors defined, and if you say something like ccat whiskers, it still works. Okay, that's because by default the compiler is providing a default constructor. But remember that compiler provided default constructor does not perform anything. So it's like an empty function. And there's garbage values assigned to your assigned. I mean, there are your object is basically initialized with garbage value. So the purpose of a constructor is to initialize your object with some meaningful values. That's why it's always advised to have a constructor. But remember, the minute you declare a constructor with or without parameters, the compiler provided one will not function. So say you have a constructor with 1 parameter only declared. So going to the previous slide, suppose you have a constructor for ccat with just one integer parameter. And I say something like ccat whiskers. The compiler goes to your class and looks for a constructor with no parameters, but you have not declared that constructor. It is then going to throw you an error. Okay. So the minute you declare a constructor, the minute the compiler finds that you have declared a constructor there, it is not going to provide you any default constructor. So if you declare a constructor with parameters, also remember to declare a default constructor in order to avoid errors in these cases. So that is one thing you'll need to remember. If you don't have any constructor, it doesn't matter. If you say ccat whiskers, it works because it's just a default constructor that you require. But if you declare a constructor with parameters, and if you don't have a default constructor there, then it's going to throw you an error. Errors can be fixed. So compiler errors is also helpful in some way. All right. So in the same manner, if you fail to provide a destructor, the compiler will also provide you a destructor, and this too will be an empty function. But for good programming practice, it's always better that you declare a constructor and a destructor, even if you have nothing to perform there. Okay. So it just makes it clearer that you are aware that you basically are creating constructors and destructors, and you purposefully do not want to perform any action in it. All right. So it's just a good practice to always have a constructor and destructor in a class. So yeah, we'll just see this example and then we'll stop it there. All right. So you've got the ccat class. So I've got a ccat. This is the first constructor. So you can see there is no return type there with just the class name. So this is the way I recognize that this is a constructor of my class ccat. You've got another constructor ccat with a single parameter. And then you've got a destructor. How do I know it's a destructor? Because there's a tilde operator before the destructor name. All right. And then you have your normal functions. So remember, the constructors of your class should be public member functions. Only if the constructors of your class are public member functions can any instance be created out of this class. All right. So I'll be discussing more about this probably in the next class, but just understand it for now. Okay. So these are two constructors there and a destructor and your normal member functions. And then I've got a single data member called IH. Since I've got an IH function, I've got two accessor functions there for the IH, that is set agent IH. Okay. And in the constructors, you can see for the default constructor, since I'm not passing any value, but I want to initialize it with some proper value, I'm just setting the IH as 0 because I've not passed any value there anyway. In the case of the parameterized constructor, I'm passing some age value. So I'm initializing the data member MIH with the passed initial age. And the destructor, I don't want to perform any particular action because, like I said, most of the cases, destructor is useful only when there is a pointer member, a pointer which has been allocated memory using new. So in that case, if I have a member pointer variable which has been allocated memory using new, then in that case, free the memory of that data member. Okay. Otherwise, it's good to just leave it empty. And that's about it. So we'll stop it at this point. So if you have any doubts, just message me. So go through your project, start working on it. And yeah, and that's about it. So we'll meet next week in that case. All right.
I have a question.
Yeah. What is that?
In Game Maker Studio, you use the functions like get age, get speed, and whatnot.
Yeah.
So with this thing,
Yeah.
so the speed, it would be, if the speed is set to 5 and you say, okay, let's just say cat. So if you say C cat and MIH and just leave it at that, would it set MIH to 5 and return 5? Or would you
You will need
have
to
to put the
specify.
int, would you have to put the int IH there and then it returns int IH because you're not putting a return type?
You're talking about the constructor over here, right? With the int age. There you will
Mm-hmm.
need to, for our code, you will need to specifically say MIH is equal to, you will need to specifically initialize it. You can't just leave it at that.
Okay.
Okay.
So to call it, I would have to put int IH within the parentheses.
Yeah, that is the parameter list here.
Okay. So
This is absolutely important if you want to pass some age. This is very important.
okay. So
Okay.
instead of doing the dot, they call it just ccat and then ccat int IH, and that'll act like the dot operator.
Which line are you talking about? Are you talking? See, within this function,
Um.
we're saying within this function, I'm saying MIH. That is the only way MIH gets initialized.
Okay.
So the reason I don't need a dot operator here is because this is within the function, within the class.
Okay.
If I was trying to access it outside the class, then I would need a dot operator. So you can see I'm saying ccat double colon ccat. So this basically means I'm trying to define this definition is happening within the class. Only when it is within the class, I don't need a dot operator.
Okay.
Okay. Did you understand that?
I understand.
Okay, all right. Thanks. Okay.
So if we were
Yeah.
to access it outside the class,
Yeah.
it would be ccat dot int I.
If you were to access outside the class, first of all, you will need to create an object out of ccat. So say something like ccat whiskers because ccat is only a definition for the class.
Okay.
So you need to create an instance first, like a variable.
Ver-
If you say ccat dot, it's the same as saying int dot, which is not right.
Okay.
Oh, so you basically create whiskers, and then you can say whiskers dot. Um, you can say whiskers dot set age and pass the age. Here for this example, you cannot access MIH directly because MIH is a private member. So if you say whiskers.mih, this is going to throw you an error.
But if I set it to public and I say whiskers dot mih, it'll return that.
Yeah, then it will be fine. You can say viscous.mih is equal to 5 or something. It'll work if that is a
And
public.
if I say
Yeah.
um, int with a public, int get age, sorry, would that return the age
Yeah,
directly
for
like
the,
if it
for
was?
returning the age, you will need to call the name of the function. So you will need to say viscous.getAge.
Okay.
Int getAge is just the declaration of the function. So if you want to return the value, just call the name of the function. So you only need to say viscous.getAge, and you will get the age value returned. All right.
And each
Yeah.
of the like little mini objects inside the function that you want to return, you put it inside the parameter, like age, weight, everything.
You need to have separate get functions for that. So
Okay.
if I have int mih and if I have int what else, maybe mi weight or something. So you have another function called int get weight,
Okay.
because each function can only have one return value, right?
Oh yes.
So that's why you need to have separate access of functions.
Okay. Thank you.
All right. Okay, yeah, that's fine. Anybody else has a doubt? Okay, so I guess you had a long day today with the test as well as this lecture. So at least try to work on the exercises, have some practice with the exercises so that you can you understand how the use of classes are, and also start off with the project. Okay. All right. So see you all next week in that case.
Thank
And
you.
see you. Thank you. Okay, I'll disconnect in the case.